So, hi everyone. Welcome to this Science of Mass Effect talk. Probably the most unique science of talk that I've had the opportunity to give. So, if you haven't seen my talks before, hi, I'm Erin Macdonald, and oh yay, Fort Collins Comic-Con is here to protect me and take care of me. So my name is Erin Macdonald. I have been a guest at Fort Collins Comic-Con for the last few years. I love this organization, everything that I do. Hi, Ken. And they're fantastic and amazing. And I am going to be talking about the science behind Mass Effect. Now, my background's in astrophysics. I am a science consultant for Star Trek, but I am also a big Mass Effect fan and gamer. So yeah, this is my alien space boyfriend shirt that we get to wear this. Hey, Adam. And we are going to be doing my Science of Mass Effect talk live in my Mass Effect game that I currently have going. So I think this will work. There may be unexpected things that we're going to have to improvise around, but we're going to go for an hour. I have notes on all of the things that I want to hit. And if you've followed me before and have seen me play Mass Effect before, you will not be surprised that we are starting out here. So this is the Citadel. This is my character, obviously. And I have my alien space boyfriend and my Krogan space baby with me. Hey, Benny. And the first thing we are going to do is listen to all of our favorite gunnery chief while he gives his recruits, a physics lesson, possibly the best physics lesson. And be aware that there is some language here, but it's just the best.
This recruits is a 20-kilo ferrous slug. Feel the weight. Every 5 seconds, the main gun of an Everest-class dreadnought accelerates 1 to 1.3% of light speed. It impacts with the force of a 38-kiloton bomb. That is 3 times the yield of the city buster dropped on Hiroshima back on Earth. That means Sir Isaac Newton is the deadliest son of a bitch in space. Now, Serviceman Burnside, what is Newton's first law?
Sir, an object in motion stays in motion, sir.
No credit for partial answers, maggot.
Sir, unless acted on by an outside force, sir.
Damn straight! I can't assume you ignorant jackasses know that space is empty. Once you fire this hunk of metal, it keeps going till it hits something. That can be a ship, or the planet behind that ship. It might go off into deep space and hit somebody else in 10,000 years. If you pull the trigger on this, you are ruining someone's day, somewhere and sometime. That is why you check your damn targets. That is why you wait for the computer to give you a damn firing solution. That is why, Serviceman Chung, we do not eyeball it. This is a weapon of mass destruction. You are not a cowboy shooting from the hip. Sir, yes, sir.
Brilliant, right? Like people were saying, so yeah, Ken said, yep, this is a different way to teach dry material. They're not wrong. And yeah, Newton's laws matter, particularly in space. And I love the fact, Cecilia mentioned this too, that this is acknowledged. And in, I think, a lot of space sci-fi, it doesn't get acknowledged that much. That when they fire torpedoes and miss, that torpedo is gonna keep going forever and ever until acted on by an outside force. So it's brilliant. I love it. Before we leave the Citadel, I do want to take us to the Presidium and talk really quick about the Presidium. So we're here on the Citadel, and if you haven't played Mass Effect before, this is Mass Effect 2. First of all, it's beautiful, and we just want to live here. That's our space dad, Captain Anderson, but we're not going to talk to him about the intricacies of space politics right now, because we're here to learn some science. If you have not played Mass Effect before, this is the Citadel. This is sort of the capital, I guess you could kind of say, of the galaxy. But my favorite thing about this is that it is round. And on the Presidium, right here, oh, thank you, Cecilia, I appreciate that. The best thing about this is it's circular, and they do specifically say that the Citadel rotates, and on the Presidium, they have artificial gravity from that rotation. So you can see if you look in both ways, there's a rotation component. Now, the interesting thing with having rotational artificial gravity in space, we've seen this not just here in Mass Effect, but we've also seen this in The Martian. We've also seen this in, most famously, 2001 Space Odyssey. The interesting thing about having rotational artificial gravity is that your ship or your space station is going to have to be very, very big, rotating at a decent speed, or very small and rotating very, very quickly. Now, again, as we just learned from our gunnery chief, Newton's law says once it's going, it's going. So trying to keep it in rotational motion is not the issue. It's more of the fact of being able to build something that big in space and get it so it's rotating, you know, at a decent speed. This is a very, very, very big space station. That's great. The one that we see in 2001 Space Odyssey actually is, it's a good size, but it's right about on that verge where the thing that you're going to be struggling with the most is actually vertigo. Because when you have a space station at that size, you want to make sure that your body, from your feet to your head, it's going to be rotating. So your feet are on the outside, your head is toward the center. And you don't want to be in the position where that height is a significant percentage of the radius. Because if it is, as you move around, you're going to experience serious vertigo. So that's one of the big issues with having a smaller space station that's rotating. With the Martian, they solved this very well by having extended arms that are able to be rotated. That's probably a more reasonable way. And then having this center area that's not rotating where there isn't artificial gravity. But we're here to talk about Mass Effect, and as you can see, the Presidium is circular and rotating such that we have artificial gravity on the Presidium. And our space boys were waiting for us, and we are going to head back to our ship, the Normandy. And if this gives anyone nostalgia feels, I mean, just go play it. It's amazing. That's a good question, Prophetic. I don't know if the issue is that as you get closer to the center, the artificial gravity is going to be decreasing to the point that it's at 0. And again, they demonstrated that in The Martian when they were taking the ladder to go out to the areas that did have artificial gravity. You could see them speeding up as they were going down. So I want to say that the vertigo may decrease as you get closer to the center because the gravity wouldn't be as strong. Ooh, that's interesting, Benny. Awesome. The Rama books. Is that the author or is that the series? If you want to put more details in, then we can share that with people. But, okay, so this is our ship. This is the sort of main bridge. It's awesome and it's pretty. We are going to go talk to our helms. Oh, thanks, Ken. We're going to go talk to our pilot, Joker, whom we love. Joker's amazing. And I just want to show up here a little bit about how this ship navigates.
What's this area of the ship?
This is the bridge, where the navigator plots our FTL vectors, and the helmsman maneuvers the ship.
Yeah, sitting right here, thanks.
That's all for now.
Okay.
You out, Shepard.
So what we're going to do is we're going to pull up the codex. So this is where we get to learn a little bit about the technology and how this all works. And I think this is in the secondary. Yes. So the FTL drive. The FTL drive here in Mass Effect, what they do, so FTL means faster than light. And I will exit out of here once we have a chance to read it. So I'll actually read it really quick because it's much prettier to actually see the bridge of the ship. But so faster than light drive uses element 0 cores to reduce the mass of the ship, allowing higher rates of acceleration. This effectively raises the speed of light within the Mass Effect field, allowing high-speed travel with negligible relativistic time dilation effects. I like that. That's similar to how the warp drive in Star Trek kind of protects your area of physics, so you're not getting that time dilation. And if you have any questions, feel free to throw them up if you're on Twitch. If you're not on Twitch, then you can head over to Twitch, and we also have a mod who's monitoring for questions there. But feel free to throw up any questions if I say something that you'd like to learn more about. So the starships still have to move to be able to engage their faster-than-light drive. And then it says the amount of element 0 and power required for a drive increases exponentially to the mass being moved or the degree it's being lightened. Very massive ships or very high speeds are prohibitively expensive. This is great. This is why science fiction succeeds a lot when they impose laws on their science fiction environments such as this. And then if the field collapses while the ship is moving at faster than light speed, the effects are catastrophic. The ship is snapped back to sublight velocity, the enormous excess energy shed in the form of lethal Cherenkov radiation. Not good stuff. Okay, Comic-Con, thank you. I appreciate that. So here we mentioned that what is helping make the FTL drive work is element 0. So let's go learn about element 0 really quick, which I believe should be in this section, and we can let him read this to us. Yes, Cosmic Crocker.
Element 0, or EZO, emits a dark energy field that raises or lowers the mass of all objects within it. This mass effect is used in countless ways, from generating artificial gravity to manufacturing high-strength construction materials. It is most prominently used to enable faster-than-light space travel. EZO is generated when solid matter, such as a planet, is affected by the energy of a star going supernova. The material is common in the asteroid debris that orbits neutron stars and pulsars. These are dangerous places to mine, requiring extensive use of robotics, telepresence, and shielding to survive the incredible radiation from the dead star. Only a few major corporations can afford the setup costs required to work these primary sources. Humanity discovered refined element 0 at the Prothean Research Station on Mars, allowing them to create mass effect fields and develop FTL travel.
Yay! All right, so let's stay on our pretty our pretty helm and talk about element 0 and how this works. So element 0 is a fictional...
Green light on that switchover?
Sorry, they're going to keep talking. Element 0 is a fictional element that only exists in the Mass Effect universe, which is great. But as they mentioned in the Codex, what it does is... when you run a current through element 0, it's going to channel dark energy, which is great, to artificially increase or decrease your mass. Now, the thing that I really like about this is because Einstein also has something called mass energy equivalence. So where we have E equals mc squared. That's energy equals mass times the speed of light squared. I actually am avoiding the armory because I don't want to talk to Jacob. There's a lot of elements in this game. We're going to go to the conference briefing room right now. All right. So we can talk in here really quick, where we have some privacy. All right, so element 0, like I said, fictional in the Mass Effect universe. Run a current through it. When that current is run through it, it channels dark energy to artificially increase or decrease mass. The thing that works really well with that is because E equals mc squared, and the thing is, dark energy is an astrophysics thing, but it's an astrophysics thing that we probably know the least amount about. So it's a good go-to for science fiction to be able to use. And they're just using the term that's like, okay, it has energy in the title, and we don't know anything about it. So that's what's going to artificially increase or decrease our mass. I have no problem with that. I think that that's fantastic, and that's brilliant. It's a great way to go about it. What dark energy actually is, the little we do know about it, is it's this energy that's pushing our universe apart. We know that something is causing our universe to expand and accelerate as it's expanding. That pressure is what we call dark energy. It's like if you want to blow up a balloon, you're going to need to have some sort of pressure in order to do that. Okay, now I remembered this morning about this scene, so I threw it in here last minute, but I haven't tested it yet because I had a very precise save file to pull up here. So So this may or may not work. But we're going to have Edie talk to us about something else in Mass Effect, which is brilliant.
This is the FTL communications room. In addition to interfacing with the FTL comm network, Normandy is fitted with a quantum entanglement communicator linked to the Elusive Man's office. This allows lag-free communication even when you operate off the comm grid.
I've never heard of a quantum entanglement communicator. How does it work?
Essentially, two subatomic particles are created in an entangled state. One is installed here, and the other in the Elusive Man's office. When one particle occupies a given quantum state, its entangled partner will always enter the opposite state, no matter the distance between them. If we alter the state of our particle, that alters the state of the Elusive Man's. This allows us to send data in the form of quantum bits.
Why aren't these used everywhere?
Each quantum pair costs nearly as much as a comm relay, and can pass only one quantum bit of data at a time. In addition to the cost and bandwidth issues, the system is strictly point-to-point. To contact 100 different worlds, we would need to manufacture and install 100 entangled pairs, one link to each world.
That's all for now.
Logging you out, Shepard.
Brilliant, right? Brilliant. Yeah, Space Rider said in here that it's clever. It's so good the way that they explain that. So this quantum entanglement concept, honestly, Edie explained it as well as anyone could at this stage. But you have two entangled particles. They remain in an entangled state such that if they change their state, the other one changes instantaneously. Instantaneously being faster than the speed of light. This is a phenomenon that we've witnessed. We don't fully understand how it happens, but there are limitations to being able to actually use it for faster than light communications. Basically, instantaneous communication. The big thing is, first of all, that they actually talk about that it would be point-to-point, that you need to have these entangled pairs. But the biggest issue, too, is that you need to be able to ensure that you have maintained your entangled state. So it's kind of like being able to have a constant ping back and forth to say, are you still entangled? Are you still entangled? Are you still entangled? And that confirmation would have to happen at sub-light speeds. So that's why using quantum entanglement for actual faster than light communication is still limited. But everything else that they say in this is fantastic. And most science fiction just says we use quantum entanglement. They do not have Caprica 6 from Battlestar Galactica as a disembodied computer voice explain quantum entanglement as well as they are here. All right. And Domestic 6000 has a question that says, would adding more weight to one spot on the circular gravity wheel, for instance, one person moving from the center to a location on the inside of the outer wheel, throw the space station off course? Would you have to add the same amount of weight to the opposite side of the wheel? That's awesome. Okay. I really like that question because this question actually came up, and let's stay in here. Literally. Okay, I'm going to let the game speak for itself. I'm not going to spend the entire hour pitching Mass Effect as a game. But we're going to stay here because it's literally the quiet place on the ship to have this conversation. So, all right. Domestic, we had this conversation on my episode club this week where we talked about Avenue 5. And the inciting incident of Avenue 5 is that the artificial gravity on this space yacht throws the entire crew into one side of the ship and throws it off course. And we went deep into this asking if that would actually happen. And that's kind of what you're talking about. We basically concluded that no, it wouldn't, because of conservation of momentum. That is your one closed system. You can't have the internal mass change the momentum of your object, because that kind of, and by change the momentum, change the direction, which is kind of what you're talking about here, right? Because momentum is tied to your velocity. Velocity isn't just how fast you're going, it's what direction you're going in. And so the inability to change your momentum, because you have this closed system, if you were able to do that, that's kind of perpetual motion-y, which physics says no. And then Andy asked, or Super DTG asked, have we confirmed information transfer at FTL speeds? As far as I know, we haven't seen that it's not FTL. That was the, we'll say hi to Morden. Morden is our favorite research scientist. That is why there are continuing experiments for this FTL communication. I assume you mean for the quantum entanglement. Some of you may have seen like a research article recently where we talked about the Chinese invented a transporter, and it wasn't so much that there was a transporter, but that they were able to sustain quantum entanglement from the ground, from Earth to a satellite in orbit. And I think from that they were able to confirm in their experiment that it was instantaneous, that it was faster than light, but there has not been reproducibility of that yet. That was a claim from that experiment, but it hasn't been reproduced. So, okay, here's our engine, our happy engine room. Let's ask Edie what happens here.
What's this area of the ship?
This is main engineering, which contains the ship's main fusion plant and Mass Effect core.
All right. So when we talk about the Mass Effect core, what we're really saying here is, remember I was talking about Element Zero, and they explained how the Element Zero, you run a current through it, and it artificially increases or decreases the mass of your ship. What's happening is, and all of you who followed me before, yes, you can have a drink because I'm doing the trampoline explanation, but when you have mass of an object, that's like a bowling ball on the trampoline. In Mass Effect, the way it works is you run a current through Element Zero, it channels dark energy, and it simulates the decrease of your mass. You continue running that so it looks like you have negative mass. Once you have negative mass, you can coast faster than the speed of light. So that's how the FTL engine, and this is our Mass Effect core, so this is filled with EZO running currents through it. That's how this works. So it's essentially turning the ship into having negative mass. Say hi to everyone's favorite space girlfriend, Tali. My favorite space boyfriend is up calibrating the engine room, and I am currently building my romance with him, so I don't want to disrupt that. Otherwise, we would go say hi to Garrus. I'm really glad you guys let me do this. Okay, so that was our quick tour of the ship. Now let's go navigate. So we're going to pull up the galaxy map. Again, if you have played Mass Effect before but haven't pulled it up for a while, the galaxy map music is going to give you hard nostalgia to play this game again, so fair warning. All right, here's our citadel. Yes, so the question is, as you approach C, or the speed of light, with negative mass, would your mass continue to decrease? So the way that they present it is that, let's say if you have normal mass, so normal mass that we have here, you're dipping space-time. You have that bowling ball on the trampoline. As you decrease your mass, you get to the speed of light, so this is where you have no mass, and then you continue to decrease your mass such that you have negative mass, and at that point you go faster than the speed of light. So you basically go sublight speed, faster than light speed. Now this is all how they explain it here. There are nuances to the physics of that, if that would actually work, but that's how they explain it. Running a consistent current through the element zero, it basically just reduces your mass and then turns negative. So you just go that way on the number line, or that way depending on how my camera is oriented. I hope that answered your question. Okay. So this is our citadel. Remember, I told you the Presidium was this ring area that we went to and visited. So this is the rotating part. And this actually says that we have a 0.3 standard Gs out here, 1.2 in the wards. That's the inner area, or that's the outer area. The Presidium is the part on the inside. So they've accounted for the fact that the radius here is big enough that when you're on the inside of the ring, your gravity is going to be different from being on the outside of the ring, which is awesome. What they also have in this game is your boots, because you can actually go visit other planets and walk around on them. There are small amounts of element zero in your suit which run a current and simulate your own increase of mass, so it feels like you're going at, that you're running around at standard G. Okay, So here are our mass relays. I'm going to use this to travel elsewhere in the galaxy. So we're going to plot a mass relay jump. And we're going to take a second here, and you can see all of the tasks that I still have to do because this is literally in the middle of my current Mass Effect 2 game. But I promise we're not going to actually go and do any of it. But I know, I have lots of stuff to do. But the important thing to point out is this takes place in our Milky Way galaxy. And these mass relays, you're going to see us travel through one, are how we get from point to point throughout our galaxy. Because this is our Milky Way galaxy. Our Milky Way galaxy is huge. And to travel, even at the speed of light, I mean, we're talking hundreds of thousands of years to get anywhere. But the lore of Mass Effect, that I'll come back to later, has us be able to use these mass relays. So I'm going to take us to the far rim to talk about one of my favorite star systems. This is our mass relay. And now we're here. So essentially what happened with the mass relay is that is a point-to-point fixed wormhole. Think Stargates, except think that the Stargates are always attached and always active. That's pretty much what these mass relays are. So I'm going to escape out of here really quick and go pull up our codex again. And I think, oh God, I actually don't remember where this is in here. He's going to talk to us for a while. Let me try to find it. Okay, so I do want to talk about Haystrom. We'll come back to that. Let me see if, yes, mass relays. There we are. Okay, let's learn about
engineering advanced far beyond the technology of any living species. They are enormous structures scattered throughout the stars and can create corridors of virtually mass-free space, allowing instantaneous transit between locations separated by years or even centuries of travel using conventional FTL drives. Primary mass relays can propel ships thousands of light years, often from one spiral arm of the galaxy to another. However, they have fixed one-to-one connections. A primary relay connects to one other primary relay and nowhere else. Secondary relays can only propel ships across a few hundred light years. However, they are omnidirectional. A secondary relay can send a ship to any other relay within its limited range. There are many dormant primary relays whose corresponding twins have not yet been located. These are left inactive until their partner is charted, as established civilizations are unwilling to blindly open a passage that might connect them to a hostile species.
Smart. Okay, I love this. So they talk about these ideas of primary mass relays and secondary relays. Think about these as wormholes. So the primary mass relay is a fixed point-to-point, as they say here, one-to-one connection that connects 2 points within our Milky Way galaxy. It can't go anywhere else. You go through one mass relay, it's going to take you to another mass relay. It's a wormhole. It's a generated artificial. The Protheans took 2 points in space-time, stapled them together, and it's fixed. These secondary relays, this is like being able to run around with a wormhole generator on your ship. So a secondary relay is where you can say, okay, I'm here, I want to go somewhere else. In that case, you actually have to build the wormhole, and that requires energy. You have to take those 2 points and staple them together yourself. And in order to do that, that takes a ton of energy because, again, to bend space-time, if you don't have mass, you need that energy. And so that's why these secondary relays have limitation to how far they can actually go. They can only go a few hundred light years, which is still great. It's still going to get you there faster than the FTL drive on your ship. But the bonus is that you can go anywhere. So yeah, Ken, no worries. So Ken Astro said, very well thought out. I love the details in this universe. As you can tell, I'm a newbie to Mass Effect. No worries. That's why we're here. That's what's so brilliant about this, is that they put a lot of thought into the science of Mass Effect, and why I'm so excited to be giving this talk. And yeah, CC, so it's point to point like the entanglement in a way. Absolutely. They're different physical phenomenon, but it still invokes a limitation to this technology that we wouldn't have otherwise, which I really, really like. And yeah, I think that's pretty much it with the mass relays. So I picked this star system. excuse me, let me think what the best way to do this is. Let's go look at the star system first, and then we can read the thing about it. So this is where one of your stories takes part in Mass Effect 2 at Haestrom. And Haestrom, there are some details to it. So every time you go to a planet, you get a whole rundown on it. This talks more about the history of Haestrom, but there's some weird science phenomenon that's going on here that I do want to jump out and talk about really quick. So you can see this is also a red giant star system, and that's going to be important to what we're about to learn about. So let's learn about Haestrom really quick, because I love it.
Before the Geth Revolt 300 years ago.
Let's see. I might be able to see.
Yep. To study the mysterious instability of its sun,
so
which into a red giant.
I won't talk over this guy the whole time.
Outpost of minimal military value, Haestrom was ill-equipped to repel Geth forces during the insurrection and fell quickly.
Let's have him say that at the beginning. So this is the important part right here.
The Quarians colonized Haestrom to study the mysterious instability of its sun, which threatened premature eruption into a red giant. As a scientific output.
So one of the cool things about the Haestrom mission that you go to is they're basically like, it overwhelms this planet. So this star is doing something weird. It is prematurely erupting into a red giant, and it's incredibly unstable. Now again, that's not necessarily, I'm going to turn this down just a little bit. That's not very scientific at all. But what is happening is they think that there is something weird going on with dark energy. Another good use of dark energy there. That's causing the star to go to a red giant, and it's incredibly unstable. The cool thing about it is that because it's unstable, this planet has a lot of magnetic eruptions and solar output, which have completely overwhelmed the communication system, as well as overwhelming the magnetosphere of the planet. Now, the magnetosphere is what protects a planet's atmosphere and surface from being bombarded from solar radiation. So if the solar radiation from this star is so high, it's actually overwhelming the magnetosphere of this planet that it can't really stand up to it. That's going to be danger zone for radiation, and that's exactly what happens when you go to do the Haestrom mission. Communication is very difficult, and you can't stand in the sunlight for very long. Now, it's a very simplistic way to talk about this risk of solar radiation, but it makes for fun gameplay, and it's a great in-universe way of having this sort of weird phenomenon that we're seeing happen. But let's talk about why that red giant thing is an interesting component to add in here. So a star's life cycle, we essentially get, I'll zoom out so we can see the pretty star. When a star goes through its life cycle, what happens is we start with a cloud of dust and gas. As that dust and gas starts to settle in, you start to have these collisions. The center gets really hot. It's mostly hydrogen and helium in this cloud. And then you start to get planets coalescing out of that. You might end up with a ring here, depending on the gravitational distribution or what happens when the planets are forming. But in the center, that hydrogen is going to get so dense and so hot that it starts fusing into helium. Once that happens, that's essentially the birth of the star. Now, talking about an average star like ours, that's going to fuse hydrogen into helium. It's going to radiate light. It's going to be a star for about 10 billion years. Our star is about 4 billion years into that cycle, so it's about halfway through its life. As it runs out of hydrogen in the center, it's going to start fusing helium. And as that helium starts to fuse, that's going to fuse heavier elements, and then you go through this process. But once the hydrogen runs out, that's where we enter the red giant phase. That's where the star starts to expand, and it starts to glow red. Now this is a pretty like standard life cycle of a star. What they're talking about in this game is this star is just going through its life cycle, and then suddenly it's like expanding, its radiation signature is changing, and it's starting to turn red. So one can infer that maybe it's just like fusing helium all of a sudden. They don't go into it any more than that. What they try to explain is like maybe there's some dark energy that's accelerating this process, and something weird is happening in the sun. And that's all we'll leave that with. So we're gonna go visit just a random planet, and we are gonna do one of the most dull/relaxing things you can do in a Mass Effect game, and that is planet scanning. And if anyone has played Mass Effect, we know about the planet scanning. First of all, I do want to point out every single planet has this codex. Even if you can't land on it, even if there's not a mission, there's a story behind it. So here we say that, you know, it's expanded under Geth rule. Geth is like the Borg. Thousands of orbital platforms surround the planet and its many moons, refining helium into helium-3. They have some more details about that, and it's just a scary place to go because of the people that are there. But they always talk about how far away it is, what the orbital period is, what the radius and the day length is, and if it's a terrestrial planet, you'll also get the gravity that's there. But we can scan the planet to pick up elements. And this is a very lo-fi version of spectroscopy. So what we do is I'm going to start scanning for minerals, and you're going to see this scan pop up on the left-hand side, or on the right-hand side. As we scan, you're going to see these elements pop up, and then I launch a probe, and it's going to absorb that. Now, this is a not very scientific, but surprisingly scientific at the same time, little mini game within the game. The reason it's so great is because what you're seeing on the right-hand side is very close to what doing astronomy is actually like. You don't as much get to see the pretty pictures on your screen as much as you're looking at scanning signatures and finding these peaks at specific frequencies, which are unique to whatever element or molecule that you're looking for and whatever bandwidth you're looking in. So where this fails from a scientific standpoint is the fact that we are only seeing 4 and we don't know what part of the electromagnetic spectrum we're necessarily scanning in. It could be optical, it could be radio, it could be infrared, it could be X-ray, and this is active scanning. So what we're doing when we're not seeing anything here, I have to actually turn the scanner on, so that's hitting the surface, bouncing off, and then we're seeing emission radiation. Of course, this could just be observing passively from the ship, so I'm not necessarily locking us into this being an active scan. But we kind of ran out of stuff here, so let's go to another one. But the cool thing is that spectroscopy is very much what we get in astronomy all the time. Again, we get some more details here. All the planets have these, so this would be just hot nonsense to try to do all of this stuff. But it's very well thought out. And then when you see this peak, what that's doing, ignore the platinum bit, but what that's doing is spectroscopy is showing us specific electrons jumping up or down in shells. Bringing back some chemistry memories. If you remember, an atom is made up of a nucleus, which is protons and neutrons, surrounded by electrons. Those electrons have fixed energy levels. As a atom gets heated up, an electron will jump up an energy level and then fall back down. When it falls back down, it releases a photon. So it releases a particle of light at a specific frequency that relates to how much energy it lost when it dropped down. All of those energy levels are unique to each individual atom. that allows us, when we're in astronomy, to actually observe space and see these emissions, what we call emission lines, which are photons being sent out from atoms as they're losing energy. So really, that's exactly what we're technically seeing here. Although the science, it's a kid's version of spectroscopy, and then allows us to brutally mine the ship and just steal all of it. But you know, as I'm scanning, what we're seeing is a high amount right now of palladium. So this means that the palladium in the planet, is giving off energy, so it's hot, likely hot, and as it's losing its energy, it's sending out these photons at this specific frequency that we can then pick up and go, oh, there's palladium there. So that's planet scanning. And there's a lot of stuff here, so I will pause here for any questions while I continue to scan this planet. If anyone has any questions, feel free to throw them up in the chat. There's a lot of palladium here. I don't think I need this much palladium. Oh, there we go. All right. And you can see we mine element 0 too. Which reminds me, I also wanted to talk about the definition of element 0. Again, fictional. But they said explicitly in the definition that element 0 is formed from the supernova of a star. So when a massive star goes past that red giant phase, it is going to run out of fuel inside. And then you have this balance that the radiation pressure and the gravitational pressure have been in equilibrium. When that equilibrium disappears because of it's run out of fuel, if the star is really massive, that radiation pressure is now gone. There's a lot of gravitation. It's going to collapse down. When it collapses down, it all condenses in the middle, and the outer layers bounce off and go into oblivion. But that's a supernova. And so what it's saying is these little planets here, when a star goes supernova, all that energy basically fries the outside, and you have a high energy reaction that happens, and it basically forms element 0. That's not incorrect. In fact, in astronomy, we've found specific elements that are formed from supernova or neutron star collisions or the like. So Ken Astro asked, is Mass Effect available for Macs? I believe it is not, unfortunately. I think it's PC. You can also get it on Xbox because the original Mass Effect trilogy was on Xbox 360, so you can actually play that on Xbox One. And then there's a later game, Mass Effect Andromeda, that is available on PC, PS4, and Xbox One. Yeah, you can get it through Steam. Okay, so we've talked a little bit about mass relays and all of this. I have mentioned that Mass Effect takes place in our own galaxy. So let's go visit our own solar system again. Okay, yay! We're home! So we can hang out. We are definitely going faster than the speed of light, zooming around our solar system here. But what I want to point out is, hey look! Our solar system has a mass relay. That's funny. Where did that come from? Let's look at Pluto. I actually have a question for the audience, if possible. I know this game came out before New Horizons imaged Pluto. What I don't know is if they did a patch for this now relatively old game to make it look like this based on the New Horizon images, or if they guessed what Pluto looked like and they got this, because frankly, that's not far off. And if they actually just came up with this image themselves before we had the New Horizon images, then credit to the team, because that is fabulous. All right, so let's read this out. Pluto is one of Sol, our solar system's numerous ice dwarf worlds. It's a dwarf planet. You can fight me about that later, if Domestic is still in the chat. And anyone else here. And it is mainly of note for being a gravitational anchor for the mass relay to Arcturus. Pluto and the Charon relay, which was formerly encased in ice and considered a moon, orbit each other. Pluto's orbit was circularized in 2157 as an effect of the Sharon mass relay recovery operations. So this is where some Mass Effect lore is brilliant. What happens is, yes, please do, Cece, I appreciate that. So the mass relay here in our solar system is what was formerly known as Pluto's companion, Sharon. What humanity figured out is that Sharon is in fact an iced over mass relay and a point to connect the rest of the galaxy. And the story of, like, the history of Mass Effect lore is that humanity discovered this, they travel through the mass relay, and there's a whole first contact war because we just blindly went through the relay. And as they mentioned, when you look at the mass relay codex, not all civilizations are just blindly willing to go through, but humanity is. One of the other things of the Mass Effect lore, uh-oh, I think we might have just lost the game. Nope, we're good. Maybe, come back to me, come back to me. Oh, I did this the other day too. We might have to reboot here, but it'll throw us right back in, so we're good. But yes, please feel free to ask that question. All right, so let me, nope. We are gonna have to old school this. All right, I will boot this up very quickly, so stick with me here. I'm staying live, I'm not going anywhere. We have more questions. It will be right back, and I apologize for that. This happened the other day. This has not happened once when I've been streaming, but it's happening this week, so I think my machine needs an update. And Cosmic Crocker, I'm really glad that you are so excited about Mass Effect that you're willing to go back because it's so good. All right. I'm not sure where it's going to load me into because I now have multiple save files going. But if it is, we're actually near the end, so I've got some cool stuff that we can throw in. All right, so let's just hit resume and see what happens. It'll be a fun adventure. Yep, stick with me, machine. Awesome, Ken Astra. Thank you for looking that up. Yeah, it dropped us back in here. All right, let's hope it doesn't freeze again because I want to go look at Mars. And then I'm going to show off some of the weaponry. And that's why I have the warning up at the top of the page. Okay, so one of the things that they discover in Mass Effect lore is that once we start, so it says, once considered a prospect for terraforming and colonization, the discovery of faster-than-light travel turned Mars into a quiet backwater. Its southern pole is a historical preserve centered on the Prothean runes found there. Immigration and development are restricted as the search for Prothean artifacts continues. So that ancient species, which we don't have to get into any more Mass Effect lore than that, that ancient species are the ones who also established the mass relays, and that's what allowed humanity to actually figure this out, and all of the details there are fantastic. So, all in all, pretty brilliant, and we love it. All right, let me double check what else I wanted to talk about. I think, I don't know where I just launched myself to. Okay, we're good. All right, let me pull up my notes really quick. All right, easy enough. So, one thing I'd like to note too is that this Milky Way galaxy that we have here is our galaxy. We just went to our star system, so it's important to note that Mass Effect, the original trilogy, takes place within our Milky Way galaxy. You can see in the background here spiral galaxies of other star systems and some sort of lone stars floating around here. But it's important to note our cosmological address. So we have our star system, which we're seeing here, is a star system within our Milky Way galaxy, one of many star systems, as you can see in this game. Our Milky Way galaxy is one galaxy in a galaxy cluster, which we call the local group, which is our spiral galaxy and the Andromeda galaxy, as well as a handful of other small clusters of stars. The Andromeda galaxy is the setting for Mass Effect Andromeda, where humanity goes through, sends basically an ARC ship to Andromeda to investigate a completely unknown galaxy. They science it very well. I won't get into as many details with that, but when we talked about the FTL drive and how that works, one of the details is as you travel, this is all the in-game science, as you travel faster than the speed of light, where your ship has negative mass, what happens is it picks up essentially static charge. Weird things happen. It's like this idea, you know, when we talk about tachyons faster than light particles, that there could be some associated, for example, Cherenkov radiation associated with that. All speculative, all theoretical, but that's what Mass Effect uses. And in this game, if your ship, our little Normandy, is traveling at faster than light speeds, it needs to discharge that static buildup on its ship, usually at a mass relay. What Mass Effect Andromeda did is they said, okay, there's not going to be anywhere to discharge our FTL drive, the static buildup on our ship. So they built the Odyssey drive. And the Odyssey drive technology in Mass Effect Andromeda essentially says, we're going to use that static charge, we're going to collect it and re-pump it into the ship. And that's going to provide the power for all of the colonists who are in stasis throughout the decades-long journey to Andromeda. Because they imposed their laws in this original trilogy, they stayed true to them in Mass Effect Andromeda. All right, I have a small side mission that I still need to do here, so we're gonna go travel, and I'm gonna show off my favorite gun. I said if we have time for weapons. We have time for weapons. You can see there's more planets here. Now we have a yellow star. We can go check out one of these planets, for example, Afris. It is in a binary system, and there's no contemporary life here. And you can see it's a terrestrial planet. All fun, awesome stuff. But we are on a mission to go do this, because ultimately there's also some combat in Mass Effect. In the first Mass Effect game, which is pretty old, you have to drive a buggy around your ship, and it's, okay, great, good. I hope this doesn't freeze again. Yes. All right, we're taking my space boyfriend and my Krogan baby. And excellent. So I'm going to take, we're going to look at some of the weapons that we have. They have some very interesting, awesome weapons. These are our heavy ones. This one, oh, I'm going to end on my favorite one because it's just the greatest. So this is the cane. This is some other people's favorite weapon. It says the effectiveness and efficiency of Mass Effect-based weapon technology has rendered large-scale deployment of highly explosive weaponry all but obsolete in infantry weapons. We've prototyped a modified version of a traditional high-explosive rounds that applied to a 25-gram slug. This is essentially the nuke launcher, even though it's technically inaccurate. Its high-explosive matrix generates an archetypal mushroom cloud on impact. Very fun to watch, not technically a nuke. Let me see what some of the other ones. These are just our typical missile launchers. The collector particle beam, this is more of like deadly lasers. Deadly lasers. I want to say here too, so the amount of energy required to create a destructive beam using this weapon is several orders of magnitude more than the amount needed to launch a high velocity projectile via a Mass Effect field. That's where they're talking about essentially rail guns. That's kind of the technology they're referencing there. But this is my favorite gun. This is part of DLC packs only, and it's the M490 Blackstorm Singularity Projector. And if for the astrophysicists who are watching this, yes, they mean a black hole. It encases particles of matter within a high-powered, mass-increasing field. So it takes particles of matter and it scrunches them all together, elevating them to near infinite mass that creates a gravitational singularity that draws nearby enemies and objects inward for a short period of time. The rapidly increasing gravity near the singularity's event horizon rips the objects apart, and then the Mass Effect field soon destabilizes and returns to normal mass with explosive results. And yes, it is as awesome as you think it is, and yes, we are about to go use it. But first, we have a question from Domestic. So moving to the speed of light, moving beyond to travel faster than the speed of light, or slowing down to the speed of light, and then going slower, according to Asimov, there's an issue not having cause and effect when you're at the speed of light. At least that's my recollection. Is this an issue? If so, is there a way around this? That's a very good question. So, with the speed of light and cause and effect, there is an issue with causality. And if, I'm trying to think if I have my, I do have my book right there, but I'm not going to flip through it. We do something called world lines, where we have time is on one axis and space is on the other. And we've condensed all of space down to one dimension, but you could think of this being a three-dimensional space down here. So this is space, this is time. In our space-time world lines, let me aim it like that, the speed of light is fixed. It goes like that. And so if you want to know if one event caused another, you have your causing event here, time passes, and your other event happens at a different point in space and time. If that event happens within our light cone, within that speed of light, then it's possible this event caused that event. If this event happens and some time passes, another event happens maybe over here, that's what we call outside of the light cone, and there's no way that this event could have caused that, because for traveling with normal physics, there's no way to communicate the effects of this event causing that. The analogy I like to use is dominoes. So imagine I have a string of dominoes set up in a very elaborate setup that's like an opaque tube that you can't see the inside, but it's a whole chain of dominoes. You can't see or hear it, but you go to tap one end, some time passes, and then the domino on the other end falls out. I cannot say definitively that I caused that to happen, but it's not unreasonable. But if I go to hit one end, I touch it, and immediately that last domino falls out, assuming I didn't touch anything else, there's no way I could have caused that. That's like that event being outside of the light cone. So all of that breaks down once you have faster than light travel. The idea of causality completely breaks with faster than light travel. And it's something that we tend to just gloss over in science fiction, even though it's a really good point. So there's not really a way around that, and it's usually just been ignored in science fiction, but I really like the question. So Benny and CC said, did some digging. Pluto's called an ice dwarf in Mass Effect 2. And its orbital path has been removed from the galaxy map. No clear photographs existed until 2015, and Mass Effect 3 was released in 2002. So they did use incorrect color, but frankly, pretty brilliant. And CC asked, they might have helped with an update or patch, but you'll need a screenshot for me, and we can go back and get that great screenshot. But we're near the end of the hour, so we are going to take our black hole gun and go do some damage. And it is awesome. I mean, when I stream, I usually stream Mass Effect on Monday mornings for me, Pacific time. Come play with us, because it's fun. And there are people in the chat who can attest to this. Alright, so I'm gonna choose my Mass Effect gun. Make sure, I gotta, like, I'm actually playing the game, so I have to literally do this. Thank you, Prophetic. Alright. And again, because I'm playing the game, we have to play the game. Alright. Get my little source of palladium. And my boys are with me. I rehearsed this, so I know exactly where I'm going to use the gun. It does need to charge up. Gotta get rid of this guy. Alright. Yep. And there they are. Here we go. There's our black hole. Everything gets sucked up around it, and there it goes. Alright, let's fire another one off here. He gets sucked in. Boom! Oh, it never stops being entertaining. Alright, so on that note, I would like to thank the Fort Collins Comic-Con team for being here. for allowing me to come in and just play Mass Effect with a bunch of people and talk about some of my favorite science aspects of this game, because frankly I think the science and lore in this universe is so well thought out, so fabulous. I love it. It is definitely my favorite video game of all time, and I could wax poetic about it forever, but the science is fabulous, and I was very happy to share it with all of you, share some of my favorite highlights with all of you. So I am glad. Thank you, everyone. We've got people in the chat just saying thank you and saying farewell. So if you're watching this on another service, thank you for being here. You can find my handle down below, or down on this side, that side, that side. Let me see the video. Nope, that, yep, there we go. And, oh, thank you for following. So at Dr. Erin Mac is where you can find me on Twitter and on Twitch. You can catch my game streams. Like I said, we play Mass Effect on Monday, so you can see me pick up right here starting Monday morning. And yeah, up next for Fort Collins Comic-Con in an hour, so at 3 p.m. Mountain Time. I had to adjust an hour and then another hour. We are going to have C.C. Peterson be giving a talk called If It's February, It Must Be Mars. So definitely come back to whatever platform you're watching this on in an hour, and we will kick it off from C.C. I will be back tomorrow, I believe at the same time, to be on a Q&A panel with C.C. Peterson, Ken Carpenter, sorry, I was staring at Ken's username there, Ken Carpenter, and Claire Raftery doing a science Q&A as well. So thank you all for being here once again. I really appreciate it, and I hope to see you here tomorrow. So thank you. Bye, everyone.